here, so I have to deal with it.
I'm here.
Well, I'll tell you something. I admire any elementary school teacher. I think that is one really hard job. Like, I love my job. I think secondary teaching is a great gig. Like, it's you get paid pretty well, and you deal with kids who are like pretty mature. They don't try to touch you.
Oh no, the kids are really liking it as a teacher.
Like,
I just don't deal with that.
when I die and go to hell, and just a question of when, I'm thinking kindergarten teacher will probably be my eternal damnation. Probably that's what's coming my way.
It's not fun.
I'm. Listen, I could just barely stand time with my own kids when they were that age. Now imagine 20 of them and there's someone else's. But everyone's different, right? Some people love that job. Just not for me. It's not. That's why they have menus in restaurants. Not for me.
I was not allowed to have recess with my own age group.
That's pretty sad.
I had to go outside. As the kids, when the kindergarten was outside, I had to go outside. I was like.
Okay, so today, listen up. Today we're gonna go pretty slow. It's not a big note. You can see that one page. One page.
1, 4, 7.
Doing my job as a math teacher. So we're gonna take it slow. It's not actually anything new. Everything that's on this page we've done, but we're gonna formalize something. What does it mean to formalize something? Sorry? Yeah, that's definitely a part of it. Let me ask you this: if I went to a formal dinner, what would I do?
Dress fancy.
Yeah, I'd dress fancy, right? I'd put my cufflinks on. I'd put a tie on. I'd probably even shave. I might not shave, but I should shave. And I would like polish my shoes beforehand. No, yeah, I wouldn't wear jeans, right? Like I would go to a formal dinner. I'd like black tie.
I would be wearing like
So that's what we're doing today. We're just taking stuff we already know and we're gonna dress it up real nice. Of course, yeah.
Oh, so we're gonna turn it into a really nasty rock, aren't we?
Yeah, but that's not gonna be so bad. They don't like it because we're gonna make sure we understand it. We're gonna make sure we understand it.
Oh, you're straight up.
Yes.
Yeah.
So let me tell you what I hate. This could take a while. What do I hate?
Immature kids.
No, that's what I get paid to deal with. No, I'll tell you what I hate. I hate black boxes. No.
That's something you say in a class.
Oh, good Lord. Okay, now listen. Let me tell you what I mean by that. Look here. Let me tell you what I mean. Here's what I hate. I hate situations in math or science or anything where we say, here's an equation, put the numbers in here, just do it this way, whatever number comes out, that's the right answer. I hate that. So when I was in grade 10, or grade 9, I guess, and we learned y equals mx plus b, which is what we're going to talk about today, as the standard equation of a line, somebody put it on the board and said, this is the standard equation of a line, this is that, do that every time, you'll get the right answer. And I did it, and I got very good marks. I was a good math student. I always got good marks in math. And so I got, high marks, and that's great. And I moved on to grade 10 math, and they told me what to do with it that year. And I did that, and then the test came, and it was the same questions that were on all the practice tests. So I did that, I got good marks. I didn't understand it. I didn't know what it meant. And because I didn't know what it meant, it wasn't useful to me. Does that make sense? I mean, if you don't understand what something's actually doing, you can't take that into your day-to-day life and use it to do something. It was something that existed only in math class. And then the second you got out of math class, it stopped to have any meaning whatsoever. I don't like that because I think math's important. I think if you're good at math, it makes you a better science student. I think it makes you a better English student. I think it certainly will make you a better shop student, tech student. And then as you move on in life, it'll make you a better trade school student. It'll make you a better tradesperson. If you own a business, it's going to make you a better business owner. Does that make sense? If you actually understand what you're doing, whatever you're doing in life, you bring it with you. Math is a movable feast. It goes with you. But only if you actually get it, if you actually understand it. And if all it ever is follow these steps, put numbers in, fill the blanks, you'll get the mark, and whatever, you will. You'll get the mark, and you'll say, hey, I got a 90 in math, got an 85 in math, got 75 in math, whatever your number is, and then you'll move on. But if you understand it, all of a sudden that's something you can use to enrich your life in other places, to make you better at the things you're doing. So we have this thing where today we're going to talk about taking a line and making an equation for it. And it follows this form, y equals mx plus b. And that sounds like some kind of mystery. It sounds like some kind of crazy thing. And I'm hoping by the end of today's lesson, when we're done this note, you're going to go, oh, I get it. I get what those numbers and letters are doing. I understand why we use them. That's the goal. So let's talk about this. A little housekeeping. I am going to use a new term. We've been talking about the initial value. Like, remember when we went to the gym and it costs $4 plus $2 for visit? What was the initial value there? What was the starting value there? What do I pay no matter what if I've got that gym membership? $4, yeah. You're going to hear another term for that we use sometimes when we look at a graph. We sometimes call it the y-intercept, and there's a reason for that. Shh. On this graph, the one you have right here, this axis, the one that goes left to right, what do we call that? What axis is this? Very good, it's the x. And what do we call this one up here? The y. Very good. So one of the ways of thinking about the initial value is it's the place where your line hits the y-axis. So sometimes we call it the y-intercept, and that's the language you're going to hear me use today. So I just want to get that out of the way, because if I don't mention it now, I'm going to be saying that word and you're not going to know what I mean. So when we talk about the y-intercept, what it means is when we're talking about a line on a graph, it's the place where the line hits the y-axis. Does that make sense? This line going straight up and down, that's the y-axis. The y-intercept is where your line hits that axis. Does that make sense? So on this graph, what's the y-intercept? Where does our line hit the y-axis? Draw a point. Draw a little point on your graph right there where it hits the y-axis. I want you to draw. I just want you to draw in here. Draw a little point. You could draw like a little eyeball or something, or like a tree, right on there, where it hits the y-axis. Oh, which axis is this? So you got it. That is an intercept. That's what we call the x-intercept. That's where it hits the x-axis. But I want the y-intercept, where it hits the y-axis. Yeah, you got it. Great. And what's the value of y there? So if that's 0, this would be?
Negative.
Yep, negative.
2.
Yeah, perfect. So we have it right there. This is what we call the y-intercept. And it happens when y is equal to -1, -2. Can everyone see that? Does anyone have any question about that? So the y-intercept is just where the line hits the y-axis. Just tell me what number that's at. In this case, it's at -2. Right. That's half of the information we need to make any line. If we know where it hits the y-axis, that gives us almost enough information to make any line. So in this case, the graph on the right, the y-intercept, is at -2. The other thing I want to know is the slope. And who remembers from the other day how we find the slope from a graph? Yeah.
Isn't it like your rate of change?
Yep.
And then like your rise over run?
Fantastic. It's going to be rise over run. So let's look at our graph. And everyone do this on your own. I want you to pick points, whatever points you like, find the rise, find the run. Just make sure they're good points. They want to be nice, good, clean points that we can use. Nothing that's like in the middle. Yeah, where's a nice point that's like right in the crosshairs? Like, would that be a good point? We want one that's like right, if you're looking in if you're looking in the crosshairs, where it's right in a corner, right like that. So follow this line, find a point that's right in the corner. Yeah, so draw a pointer. Great. And now we want rise and run. So connect them by rising and then running. Connected to, you could use that point. Just make a dot there. Great, so those are going to be your 2 points. So rise. How much is that? How much did you go up? 1. Perfect, so write that. Say rise equals 4. And then run over and say how many that is. Can I see?
Go down.
Yeah, totally fine. That looks great. That looks great. So now just tell me what the rise is, tell me what the run is.
Okay.
Can I see? Okay, so tell me what's, you go, you're good. I don't even know why I say anything. I have nothing to say. It's all boring. Good. Though I guess I can say one thing. 2 divided by 1. Can we just express that easier? 2 divided by 1 is just, no. You have $2 and you divide it amongst just one person.
2,
yeah. 2 divided by 1 is just 2. Anything divided by 1 is just itself. So that's a right answer. I like it. It's perfectly fine. But you can make it even easier. You say 2 equals 2. But yeah, that's great. Can I see? Okay, and what is 4 divided by 2? This is totally good. Good, so put that. So that equals 2. Okay, so there's no one way to answer this. You could have picked any number of points. I'm going to pick this point here and this point here, but you could have picked any. It does not make a difference. And then we rise and we run. In this case, how much did I rise? What's my rise here? Yeah, 1, 2, 3, 4. So rise is equal to 4. And what's my run? Whoa. My run is 2. Good. Okay, so what is my rate of change then? What's my slope? It equals what over what? In my case.
4 over 2.
Very good. And what is 4 divided by 2? Very good. So my slope is 2. If you leave it as 4 over 2, it's kind of not great math manners. That's kind of a messy answer, but it's a perfectly correct answer. It's totally true. Nothing wrong with it. If you had it as 2 over 1, totally a correct answer. Did anyone do 6 over 3? Did anyone do a big triangle? No? What was yours? 2 and 1? Yours was 2 and 1. What was yours? Same as mine? Cool. All right. So there we go. Now, here's what we want to do today. I want to be able to make an equation that will let us, and this is key. This is like the whole crux of this unit comes down to what we're going to talk about right now. This is central. This is key. So I want to make sure I've got everyone's eyes and attention on me. I'm the center of attention. Then I feel special. Look at me. Okay. What we want to do is this. We want to be able to make an equation so that we could find any point on this line. Okay? And here's what I mean. We use these relationships for things like gym memberships, right? Where we said, if I go to the gym, it costs $4 plus $2 per visit, right? When I was in the restaurant industry, we talked about this yesterday, I used this for ordering food. So look, keep where I'd say, hey, if we're gonna have 200 guests tomorrow, how much bread do I have to order? How many steaks do I need to make sure we have in the fridge? I would do all that ordering based on our numbers. How many bottles of wine do I need to have in the cellar? What we want to be able to do is pick our X value. So I could look and say, okay, I know 200 people are coming tomorrow. That's my X value. I want to know how high to go up on the Y-axis. I want to know how much food to buy. Does that make sense? We want to make an equation so that we can always pick whatever X value we want, and the equation will tell us what the Y value should be. That make sense? In the gym membership, I should be able to say, hey, if I went to the gym 12 times this month, nope, what's that going to cost me? And the equation will tell me that. That make sense? So for any linear relationship, the equation will make it so that we can put one of the numbers in, and it will tell us the other number. That's what these relationships are all about. If you take one thing away from today, take this away from today. The whole idea is, when we make a linear relationship, we make it so that I can say, hey, equation. If I am driving 300 kilometers, how much gas do I need? Hey, equation. If my class has 20 students, how many pieces of paper need to be in the photocopier for me to print this test? That'd be a linear relationship. You tell me. Hey, equation. If I'm going to have 7 employees working on Saturday night, what am I going to have to make sure I have in the bank to cover my paychecks? I tell it how many employees, it tells me how much money. And then I can say, oh, we just got another booking. What if I had 8 employees? It gives me the new number. Does that make sense? So the point of an equation is that you're going to be able to put one piece of information in, and it will give you the other piece of information. Does that make sense? That's what this thing is all about. So I don't want what we're about to do next to be some kind of crazy thing. The whole idea is there's always a number that we can set. That's what we always call our X value. The X is always the thing that we're in charge of. That make sense? So if we're talking about how many people versus steaks, I have to tell the equation how many people are going to be in the restaurant. That's my X value. That's my input. That's what I tell the equation. And then when I use the equation, it will give me the Y value. That's the output. It's going to tell me how many steaks to buy. And a different equation is going to tell me how many employees I need to make sure I have working that night, so we have enough staff. There's the piece of information I put in, and then the piece of information that it gives out.
This is mine. You like the input-output chart, right? You elementary school.
Yeah, and that's exactly right. And I always wish that I would love to be able to spend a few weeks like talking to elementary teachers and know exactly what they teach you guys so I could refer back to things better. Because they actually do a great job with those input-output charts, setting you up for this.
If you have the right teacher.
If you have the right teacher.
Don't you do great?
So it really is the idea that we use linear equations to help us solve problems. And the way we do that is we put a piece of information into the equation and it gives us a piece of information out of the equation. By the way, some form of that is every computer you've ever used, right? You put information into it, it puts information back out at you. You press a button on the computer, it puts a number on the screen. The computer's just doing equations like this too. It's just doing hundreds of billions of them really quickly. But it's the same idea. So with that in mind, we're going to talk about this information, which we already know. We know how to find the y-intercept. You just look on the graph. We know how to find the slope. You just did it. You take rise, you take run, you divide them, you get your number. How do we turn that into an equation? Well, that's this. Did you guys see this form last year? Y equals mx plus b. Is that familiar? Some of you did. Some of you did not. That's what I'm hearing.
Remember doing it last year.
Seen it, didn't talk about much, black box, use it, put the number in, blah. Okay, good. That's not what we're doing this year. This year, we're going to actually look at this, and we're going to get it down in note form. Then we're going to spend like 5 days working with it. We're going to do some days on the computer, hopefully tomorrow. I forgot that co-op had the library booked all day today, or we'd be there right now. But we're going to spend some time doing some stuff on the computer with it. We're going to spend some time doing it by hand. We're going to spend some time applying it to real-world situations, but we're really going to learn how to use this. But here's the idea. I've already told you that there's 2 things that the equation is really focused around. The x is the input. I like that you mentioned those input-output charts, so I'm going to mention that. The x is the input. This is the number that we provide to the equation. And it's always going to be different, One day I might use my equation to tell me what happens if there's 200 guests in the restaurant, and then Saturday night comes and I'm going to have to say, hey, what if there's 450 coming through? The x is different every time I use the equation. The x is the thing that I set. It's the input. And the y, well, it's all by itself on the left. That's the number we're going to end up with. We're going to end up with y equals 53 steaks, Joe. Make sure you buy it. Y equals 200 liters of gas. Make sure you have that much in your tank if you want to go on this trip.
No, they got it.
Y equals, might take a few stops. Y equals 85%. That's the mark the kid got when we put all the stuff together. Those are equations too. That's how I figure the marks out. I let a computer do it, so I don't have to do math. But that's what the computer's doing. So the y, that's the output. That's the whole point of doing this. This is the solution. It's the answer. Y is always the answer to your question. It's the output. And I want to stress this. When you make an equation, y is going to be there written as y. X is going to be there written as x. Because an equation is waiting for you to give it the x so that it can give you the y. So an equation that is like y equals 3x plus 5, that's like a car in the driveway just waiting for you to get in and drive it. It's got all the pieces it needs, and it just needs you to tell it where to go. You put the x value, it drives you there. It gives you the y. So I guess it's like a self-driving car in the driveway. Wouldn't that be nice? Just get in and you can like read a book.
All I want BMWs.
Yeah, I saw that. Like that people actually now have cars that like they can just say.
People are getting really lazy.
Listen, I think, like whatever. I have a short drive. My drive here is what, maybe 25 minutes from St. Catharines. That's fine. That's no big deal. But you imagine these guys who drive like an hour and a half to Toronto every day from Burlington or Hamilton or something. Could you imagine now if they could spend that time like reading or napping or? It's going to be safer. Yeah, I think it's a good thing. Okay. So now they leave us with these two letters, and this is where we all just have to agree to something. People who make the rules for math are stupid. They're not stupid. They're really smart. They're really smart people, but they do stupid things. Sometimes smart people do stupid things. So ready for a stupid thing that a smart person did? The letter M obviously stands for. Cassie Sparks, what's M stand for in this equation?
Mitosis.
No, not mitosis. Come on, what does M stand for? What starts with M? Oh, right, slope. Slope starts with M. Just kidding. No, it doesn't. Yeah, so this is one of those things I'm talking about where math people.
Starting to get you.
Okay, once you know the slope, that's what we put where this letter M is. They use the letter M to stand for slope. Why?
Why not?
I spent like 2 hours the other night on the internet researching why they used the letter M so I would have a good story to tell. And I was hoping that it would be like a guy named Mike came up with the idea, so he made it M. Nobody knows. Nobody knows. There's a few like harebrained, stupid explanations, and none of them make any sense. None of them pass the sniff test of believability. It kind of looks like ski slopes, maybe, so you could think of it that way. For whatever reason, they use the letter M to be the slope, and they use the letter B to be the y-intercept, that initial value. I don't know why. I wish they used like S for slope and I for intercept. But they don't. They use M for slope and they use B for the y-intercept. The stupido. Yeah, it's Italiano. Un poco d'Italiano. Okay, so if you look at this, we can take any graph and we can turn it into an equation if we know two things. The y is just going to stay a y. That's just waiting for us to put a number in. The x is going to stay an x, because that's waiting for us to put that number in. The only two numbers we need to make this equation are slope and y-intercept. And if you know the slope and if you know the y-intercept, you can crack the code of that line. You can figure out its equation. The equation that will let you find any point on that line, as long as you know the slope and the y-intercept. So let's take a look at this. If we wanted to make one for this line right here, what is its slope? Well, we said it was 2, right? Because its rise over run was 2 over 1. And its y-intercept was -2. So we can put those two numbers into this equation. The equation for the above line is y equals, what is the letter M again? Slope. So what number do I have to put here? For a line on this graph, what's the slope? 2. And then the x, what do I do with it? I know. We just write it. It's waiting for our input. The x stays in the equation. Your equation will always have a y in it, and it will always have an x in it. So y equals 2x, and then plus b. What's the b again? -2. So I'm actually not going to put plus, I'm going to put minus 2. 2x minus 2. And again, we're going to keep in mind that that is the slope. And that this number is the y-intercept. Okay, now why in the world do we do this? We do this because now we have an equation that we can use to find any point on the graph. Okay, and again, for this graph, we're just dealing with numbers. But if this is a graph that's been designed to tell me, hey, I own a company that makes, I mean, a real simple one, but say I'm making cars. If I have an order for 1,000 cars, how many tires do I need to make or buy? I'm probably not going to make the tires myself. But if I'm a car company selling cars and I've got a, that's right, I'm making 1,000 cars, how many tires do I need to order?
4 or 5, depending if you want to put a spare tire.
That's true. So let's say no spare tire. Let's just say just basic. 4,000, right? Does that make sense? That's a simple equation. Now that's a nice simple equation because we're just multiplying by 4, right? But if I'm that same car company making 1,000 cars, you know, how many front seats do I have to buy? Front seats.
4,000.
2,000, right? How many steering wheels do I need to buy or order from my own company? Just 1,000, right? Does that make sense? Each one of those would be a different equation. So here, and then the next day, if the next month my production is supposed to be, you know, 6,000 cars, I can use the equation and get all those numbers again. Yeah. So, and again, listen, if you manufacture, if you build stuff, you have to have all of those calculations. You have to know if I'm building this, and it gets complicated because if you manufacture 5 or 6 different things, well, all of those things may use the same bolt, right? So they may all use the same springs, but they use different metal plates, whatever. It gets complicated. So we're going to teach you how to deal with that. So here, once we have an equation, we always input the x, and it will give us the y. Does that make sense? We give it the x, it gives us the y. So for this graph right here, let's see what happens when we give it an x of 3. How would I write that? I'd say y equals 2, x minus 2. That's the equation. But instead of x, what am I going to put here? 3. Because we're saying that x is equal to 3. Does that make sense? And now we can do this in our calculator, which, did Cassie be so kind to go give everyone? Thank you. I mean, this one we can do in our head because we're smart. What's 2 times 3? No, 2 times 3 is? Almost. I don't like you. 6 is right. And 6 minus 2 is? 4. Very good. Okay. So look. So when x equals 3, 2 times 3 minus 2, 2 times 3 is 6, minus 2 is 4, y equals 4. So in this thing, you know, if there's 3 students in the class, I need to get 4 pencils. Because not only will every student need a pencil in the middle of class, let's say Noah will chew on his and break it and need another one. There we go. So 3 kids in class, I need 4 pencils. So now we can go see if that goes on the graph. What was the x value we put in here? No, the x value I put in. Thank you. I put in an x value of 3. And what was the y value it told me that matches up with? I'll remind you that nobody likes you. What was the y value we get? When we put 3 into this equation, what y value does it give us?
4.
Thank you. Okay, so let's go see if we've done this right. That point should land right on our line. So let's go look. Up on this line, if we go over 3, 1, 2, 3, and up 4, 1, 2, 3, 4, does the point 3, 4 sit on our line? Yeah, of course it does. It sits on our line perfectly. Does that make sense? Whatever x value you put in, it will tell you how high to go up on the y or how low to go down. Now, in this case, I picked numbers that all fit on the graph so you can see. But eventually, we can do this for numbers that don't fit on the graph. We could see, what if x is 2,000? Well, now you see why the equation's useful. If I had to make the graph go all the way to 2,000, I'd be here all day making a graph. Yeah, whereas with the equation, it's just as quick as all the others. So I want you to try the next 2. Tell me what the y value is when x is -2. Tell me what the y value is when x is 0. Take a few minutes, do the same thing we just did. I'll come around and look and say encouraging things like, hey, good job, you're doing great. Or just keep trying. Yeah, you bet. Or get off your phone. You know, whatever I have to say. Well, oh gosh. Yeah. It seems like the answer to that question would be yes, and now I'm hoping you might be less than that. Just falling off. So, the idea is
Yeah.
is so that we can how high up or how low down you go, so that balance falls right on. Does that kind of make sense? That's what this equation is. All the equations don't do. If I tell the equation what tell you is, it'll tell me how high up to go, or how low down to go. Does that kind of what that makes sense? Cool. And the way the equation works is you can always find y by taking the slope. If you just find out the growth, which you didn't. I mean, that's what it's doing. Right? You want one slope of always runs over one. Well, no, section you can make two over one, right? That comfortable?
But if you're taking away
So you say slope of 2 times whatever x I put. If I pick 5, you tell me for 5. If I pick -5, you tell me for 5 raised to 1,000, you tell me what the x is. Does that make sense? So you can slope of times the x out of your own, then add you want to check out. So you come to 491. Cool. So what I want to say is, now, this one, you can do this one, right? You do this negative. When you go to -2, how far down? I just don't know where I can only go.
That's, I know what it is.
But I swear to God, if it's the minus, it's not the minus.
We know that y is equal to 2x.
Oh, no, you can find a negative.
And minus 2 is so let's say y equals. How do you do it? If negative 6.
Yeah, negative 6.
And then set that. It's the number I told you. Yep, very good. And then you watch it. -6.
Like a negative 2.
Negative 6. How are we doing, yeah? Let's see what these are doing next. Oh, I know what it's like. You have to use for negative 93 and 10. They get lights that have bright.
I'm hard to like that.
Negative.
I'm just gonna write this up. So what I'm going to do is negative 2 on the x. Comma. Negative 6. Negative what? And then we'll put that point on the graph. Negative 2 on the x. And negative 6 on the y. So you're not plotting the points.
We still won't name you.
Negative.
So negative 2 means 2 over, and the negative 6 means 6.
Negative.
Does that make sense? So put that point on.
You guys
2
got
over
okay, no
2
problems?
less 6, yes. And does that land on your line? That they solve it, they will. You know, they solve
Right,
it.
you go down to negative.
Do I want new shoes? I think
Now, there we go.
Yeah.
All right, let's talk. So this is like, don't find it confusing because this is new.
Yes, you sure?
Yeah.
But like a little like, stop.
Are you taking a selfie? No. No? Is this to adjust your hair? Can I see it? I need to. I need to just.
Is that a star, David?
Yes. Oh, I'm
When you find David, then give our signs. Like, it's a bit annoying.
No, you're doing it wrong.
Why am I doing it wrong?
Because you're going on the positive side of the graph. The left x negative. Wait, it's just extra white.
Whoa, is this
Well,
gonna
you
be
like
like?
you throw it back.
If I click that, is that what's gonna happen? No, but it's true. If I click this live unicorn.
I'm looking.
You're gonna
Oh, yeah, I know now.
Go down
Okay,
six. And to the left, 2 to 3.
I look good.
5, 6.
Over and negative 2.
Right here.
Brody.
What?
Like the notes when I
Thank you.
Well, that was the greatest moment of my life. Now, I hope I never have to see that again. Now let's talk. Okay.
I found it.
Oh, fun.
Let's go.
I see now why nobody pays attention. I've been wondering this whole time. Now it all makes sense. I never knew I come around and the tongue like that was really long.
I finished.
I had no idea. Okay, I'll be right there. I promise.
You end on this, right?
No, you didn't.
No.
Talk to each other. I want you to go talk to one another. See if you
Dawson, come here.
See who's saying.
Did I just say into one?
The idea is that we can tell people what X value you want to use,
Like yourself.
how far we want to go right.
I want to see what Dawson said.
How much we have to end up on. Does that make sense? We tell it.
Oh, Ashley.
Yes, you do, Dawson. You have to put on this.
Let's compare and put it on the thing.
Tell me what. I can try again. Okay. So, here's your right? All we need to make that is the slope. Which you found here. That's what we're running. Cool. And the line type before we use, look at the graph we point at. Those two things.
We got 4 people right here. So you have to do it for like,
And output, but why are we looking at it? It's going to be the slope times x, and our slope is 2, so 2x. If our slope is 3, this would say.
The wall?
Go to the wall.
5 over 4, this would say.
It's breaking.
Don't build an
5
escalator.
over 4.
Yeah.
It's exactly that.
You gotta run up and down this.
And then the y-intercept.
I get some of
So
it.
you say minus 2. If our y-intercept is at plus 5, you would say.
Oh my God.
Does that make sense? And that makes our equation. Now we can use, the way we use it is we say, okay, what happens when x is equal to 3? Well, now I've picked, I said I'm going to go over 3, hey equation, tell me how far up to it. And 2 times 2 has 2. So that means go up and down. And there's a point.
Like the kid got away with
Does that make sense? So here, we're going to tell you
You see what's gonna
equation. What happens when x is negative 2?
She said that.
We already know the answer, right?
Oh, I was.
When x is negative 2. Yeah, when
I'm
x is negative 2.
pretty sure you have to have a party now.
That would be 5. You're negative 6. So we already know the answer. We know the answer is going to be negative 6. Let's make sure that's true. That's this equation. So this is 5 variables now. Okay, right. It's interesting. X, and I've already said, we're going to use it. We're going to use for X.
The sun.
No, what are we going to use?
Like on there.
Yeah, X is equal. Minus 2. We're looking when X is equal to 2. So instead of writing an X, we're going to open a bracket. We're going to say, oh, I know what X is. Negative 2. Listen, that's what
Oh my God.
Always replace the X.
But yeah.
Right? That's what we set up here. X is the input. We set that.
How's that going?
So when I write this.
Oh, maybe you're getting squashed to death?
Yeah, I'm going to write it. So you open the bracket and put the number on the
No.
If this was my mistakes.
It's a bill, which is like space between.
I've got 100 people.
You're getting.
It's a bill,
You're getting stuck on the moment you get compressed, you're done.
Why?
It's not even.
Does that make sense? So if you choose the bracket, and tell the equation.
It's a bill, we're fine with that.
Okay,
How do you say that? Rather than do?
Yeah, minus.
It's just totally killing you.
You see it though?
Right there.
Let's do this on it.
Holy chain.
The gear, the gear crushes you.
Wouldn't they just crush your leg?
It would crush your leg.
She literally fell, and it was right here.
Yeah.
That's like your
It's just like
your stomach, your appendix.
Look, here is.
So what are we looking at?
We're watching a news
Do
article.
your math.
We don't have
I'm
any
finished.
guns.
Do your math.
I'm finished.
Maybe not.
We're
Let's say,
actually looking
now
at my estimate.
what did I put in
Yeah.
as an X
Did you
value?
get the right answers?
Did you take my pencil? Oh, no, to my pocket.
What Y value did it give me?
This time continue.
I know, right?
You put that on the graph.
I did.
So that they look like-
Yeah, no, so 6 something.
Did that land on the line?
Like,
Good.
like,
Like Brody.
Get down.
As that one on the line.
Yeah.
Okay, gentlemen, grab your seats. We're gonna take these up. Gentlemen, grab your seats. Good, we're gonna take them up. Grab a seat. Thank you. Okay, so again, I just want to talk you through this, and we're going to talk ourselves through a lot. We're going to go really slow with these. We're not going to do a million examples. We're going to do a few examples, and we're really going to talk about all of them, so we feel like we get it. So the idea with this is, for this line on this particular graph, I've found the information I need to make an equation. I need to know the slope, it's 2. I need to know the y-intercept, it's -2. So y equals the slope times x, which is 2, minus 2 because that's the y-intercept. Now I can use that to find any point on the graph. I have to put the input in. I have to tell the equation what input I want to use. The input is always the letter x. That's the number we tell the equation. In this case, what number am I telling the equation to use for its input? What? Yeah, I'm giving it an x value of -2. So when I go to write the equation, I rewrite the equation. Y equals 2. But when I come to x, I don't write x. I open a bracket and I input the number I want it to use. In this case, -2. And then I have to keep going. I'm not done because what's the rest of this equation? Yeah, subtract 2. Just like that. And then you can do this on your calculator. We can say 2 times -2. Your calculator doesn't need the little star, mine does. And then subtract 2. Does it? Okay, there you go. And the number it gives me is -6. So there we go. And now, yeah, I always like to write the point because it reminds me why I'm doing this. What I told the computer is, in this case, what I told the calculator, which is just a computer, use an x value of -2. And when I did that, it told me that the y value was -6. And I'm going to go up and put that on the graph just to show that it does indeed fit. I'm going to use orange because I like orange. I have a firm belief that if you leave like a bunch of drinks in the fridge, orange juice always gets drunk first.
Yeah.
Like if I have like 50 different things to drink in my fridge, my kids will always annihilate the orange juice before everything else. There's just something about the color orange that looks thirst quenching to me. Anyway.
Orange juice is just what?
It's so good. When you get to be a little older, you'll start watering it down. You do like half orange juice, half water. Just saying.
Why?
It's too sweet otherwise. Okay, so let's look. -2, -6. There it is. Is that point on the line?
Sure.
Yeah.
Oh yeah.
Good job.
Oh god, dude.
Great.
Oh yeah.
Because that's what this equation does. This equation does only one thing. When you put an x value, it tells you the y value that will make it land on the line. It tells you the y value that will make it fit the relationship. So really quickly, super quickly, how do I solve this one? When x is equal to 0, what do I do? Y equals
2, then bracket 0.
Good.
Then bracket -2.
Excellent. Okay, we can do this one in our head. What's 2 times 0? 0. 0 minus 2 is almost -2. Good. There we go. So when we do that,
Your point would be bracket 0.
yep, very good. Oh, go away. Nothing in it. It just says mark. What am I doing tomorrow night? Marking. Lesson prep. Actually, that's not true. What am I doing tomorrow? Going to trivia night. Yeah, you still trivia.
Yeah.
I'm very trivial. Okay, and let's try.
19 over.
Is it?
Yeah.
Well, that makes sense.
Yeah. Like what? That's what I'm saying. Wait, what?
Presumably, so we can drink alcohol. I don't know. I don't know. Or maybe it's just like, wouldn't it be nice to spend a day at Eastdale without all those rotten kids around? Just saying. Okay.
Go the same with rotten teachers.
So 0, it might go more with rotten teachers. I don't know. All right, and 0, -2, does that land on our line? Of course it does. Now, as it happens, I picked 3 x values that land on the line so you could see them. The nice thing with this is, if I wanted to know what happens when x equals 1,000,000, I don't need to make a massive graph. I just plug 1,000,000 into the equation. and it would be 2 million minus 2, so that's 1,999,998. There we go. Boom, done. I know my point. That's right, in my head. Yeah, look at me. Okay, so this is it. This is all we're doing today, right? This next bit. I want you to try a couple. For these two lines, I want you to find the slope. I want you to find the intercept. I want you to tell me the equation.
All right, never watch it.
Of course. So for both these, find the slope, find the intercept, tell me the equation. Find the slope, find the intercept, tell me the equation. Then for the next question, find the slope, find the intercept, tell me the equation. Ready? So, sit up. I'm going to get the end of pull your head so you sit up. I got still fine. So just to be clear, in that equation, I'm good, right? I don't get hurt. Yeah, we're good. That's fine. I call your bluff. Pull her head. Okay. So let's get to work.
It would actually be very good practice. I almost got quick last night and then the night before that. At the same park with the same person.
Oh, no, I just thought of this.
3 over 4.
Yeah.
I
I actually don't know. Did you eat 5 of 6 right now? I would totally do that.
What's the depth?
Just that. With milk or without? Okay, that's fine. I mean, it's still weird because chocolate milk can never be chocolatey enough, but at least cutting it with milk makes sense. If they cut it with water,
He sometimes doesn't.
I'm not a sweet person level,
Yeah, you put for B again.
but I like chocolate milk to be sweet.
Yeah, I do too. Sometimes, like, you know, it's just like, and I do.
Now you can answer it.
It's like, no. It's I rotate back.
You gotta balance.
Okay, what?
Let's take a look. So,
It's that you got wrong.
we need 2 things. We need M.
No.
And M
Yes.
is that would be used for what?
Yes.
Yes, I can. As we all
We think Josh.
It's all I know done.
You're not. About that.
Stop it.
If I split my wrist,
I don't get it. It's all I know.
I'm to make a tape.
Why is?
Right?
I get a lot.
I always think that one might be like base.
Welcome to your tape.
I was thinking,
Well,
Wrong.
that one at least makes more sense. Basically, why again?
Oh, yeah, it's wrong.
If you answer
It
it.
all fits.
I was
When they get the answer.
what happened last.
Did you do that? Did you do that?
She's literally like,
Just draw rid of as line.
let's.
No.
Let's do this right now. Let's do that.
I wish I did, but I didn't.
Oh my god.
You're in the woods, but I want to get my.
Oh, okay, I get this.
Well, but I'll get them covered in your blood. Wood chips, okay, now. So, yeah.
So,
One of her friends stood up, like,
Just like me.
stood up for, literally.
Nicola's always got my back. More than that, it's always this.
Am I doing this right in this room?
so why intercept better? Why intercept?
Yeah, that's a great.
There, let's go.
That's great.
Go. Y equals 3 over 4x plus.
What happened last night?
You're
You're the same one?
Yeah, so now get your lines and get your.
Experts, right?
Yeah, yeah, so that's great. So
You
that's
do
what you
any point you want.
Like, he was like,
As long as those are good points, those are great points. As long as they're in the crosshairs. Nice.
she's like.
I didn't find out.
-1 here.
Okay, now, if they want you to.
Okay, so I want you to tell me, we need to know the slope and the y-axis. Y-intercept's easy, it's just on the line, it's the y-axis. Here, it's right there, I'm using this one. And it's the y. Okay, does that make sense? Let's look at this line, this is the line. Yeah, of course, please. And what's the y though? What's the y? Zero, so we're going up to there. On the- Yeah, positive three. Okay, so tell me what it is. Why does this actually equal?
Oh,
I need a ruler.
And we usually call that y-axis. There, we use the y-intercept. Yeah.
Good.
I know this is stupid. Listen, just say born.
I don't know.
Oh, Lord.
It
All right. All agreed, stupid, now we find the slope. The slope, yeah, pick two good points. I want a good point already, but that was a good plot. I need good ones, yeah. I find the lines my.
oh.
Boom.
So then right here, what's the what? Right in the middle. Slope is 1 over what?
Wait, mine.
I finished it.
Yeah.
He's different board up here.
It's wrong.
It's, oh.
Now we're able to have you make an equation, right? Y, that stays a y, equals, the half middle, and the gamma, x stays x.
1, 2.
And then plus, y
And
equals x. Get it out. Y equals. Oh, and m is x plus b, and right?
What was the slope?
2. It's right, bro.
Alright, neat enough. No, it wasn't. We're gonna be so neat that people are gonna say, oh, I'm gonna say, I'm gonna check the B. Plus, and what's the B?
Well, you still have 3 more lines.
No, one more thing I want to do.
Stop.
Let's
You
look at
were
the
really
side.
wrong.
Is this still going up or down?
Oh my
One negative. Does 2 negatives make a? Yeah, so we want 2 negatives. So 6. Great. Good. And stick with the fraction, like, because it will give you an upper number, just leave it sort of right.
Right here, she has, x is 4, y is 6, this is right over.
Yeah, okay, so it's the right.
Look, word, that's a whole x-axis.
I don't care.
You're supposed to put it on the y.
This is the rise, then you're running in for. Yeah, right, right. So this would be 6 over. That's okay. That's okay, that's how we want it. That's good. I like almost everything. I like almost everything. I don't want the decimals. I want a fraction. That's one thing. The other thing I don't like is, I like the number, 3 over 4 is cool. Is this going up or down? So it should be positive or negative. Negative slope. Good, so it's negative 3. Other than that, I like everything. Other than that, I like everything.
So then try this and it has a fraction.
Yeah, put it in the equation as a fraction. Hey guys, can we take the first of these up together? And then we'll do the second one if we have time. If not, we'll do it tomorrow. So let's talk about this one. So I need to know 2 things. To get my equation, to get y equals mx plus b, what 2 things do I have to know? Well, I have to know m, and I have to know b. Very good. Well, the x and the y stay in the equation, right? Because they stay in because that x is going to be my input. Once I have that equation, like I said, now it's like having a car. If you have a navigation system in your car, or if you've got a navigation system in your phone, you don't want it to come programmed to take you to Boise, Idaho. You want it to come with a blank slate, right? Where you can tell it where you want to go. If they sold you a GPS, big, beautiful GPS, and the only place it could take you was like the 7-Eleven in Welland, it'd be a pretty useless GPS, right? If that's the only place it ever pointed, You want it to be able to you to input whatever destination you want, right? That's like an equation. We don't want it to have a number in for x. We want it to have the letter x because that is the input. That's like the keyboard on the computer telling us, hey, put the number you want in here, and I'll tell you what the output is, just like your GPS. You put the address in here, we'll give you directions. So an equation should always have an x in it, and it should always have a y in it. That means it's ready to go. We're ready to use it. But it's not ready to go until it has a slope, an m, until it has a b. And again, it takes a bit of practice to get used to this. So let's go with the y-intercept first. How do we find the y-intercept? What do? I got my line here. Where's its y-intercept? Yeah, you just tell me when to stop.
Stop.
Hey, look at that. That's its y-intercept, right? Okay, so b is equal to what? 1. Is it negative? Right? Positive 3. Cool. I like it. So b is equal to 3 because it's up here. The other thing I need to know is the slope, which I get by picking 2 good points. And I'm going to pick the points you picked. What points did you pick? You picked, was it -4 and 6, this one here? And then what was the other point you picked? 4 and 0?
What? You do all those?
Yes.
Like these ones here? Okay, perfect. Let's do that. Gentlemen, I just want to make sure you're on the same page as me, okay? So I have picked these. Now you could pick a different rise and run. That's okay. If I pick this one, what's my rise? 1, 2, 3, 4, 5, 6. So rise is equal to 6. What's my run? What'd I get? Run is equal to 8. How do we find slope? Rise over run. So m slope is equal to rise over run. And in this case, that's 8 over 6. Now that answer is fine. You could leave. Oh, right. I'm just testing you. I'm not testing you. I just made a mistake. Now let me ask you the last question. Is this slope going up or down? Down. So I need to make it negative. Okay. Shh. Now listen. When we go to make this an equation, we say y equals mx plus b. Now this -6 over 8, you can put that in there. You'll get the right equation. It will do all the right math for you. You're dealing with bigger numbers than you need because can we make this fraction simpler? Can we divide top and bottom by something? I'm going to divide them both by 2, and that will give me negative what over what? Negative, what's 6 divided by 2? 3. And what's 8 divided by 2?
4.
Oh, which is why I wrote an 8. There we go. Good. Now, again, if you use -6 and 8, you would get the question right. You'd get all the questions right. It would work 100%. You'd just have uglier multiplication to do, which is fine. But I'm going to put this in here. Y equals m, which is 3 over 4, x. And then what's my b value? What's my b value?
3.
Plus 3. Good. Now look, let me show you something. We're going to use a piece of computer software called Desmos, and we're going to use it a lot, like lots. And the reason is it can graph things for us incredibly quickly. So instead of you graphing things by hand, often, put it down, write it down, out of the way. Thank you kindly. Okay, so let's put this equation in here. Y equals, what did we have? -3 over 4? Oh, I didn't make it negative. -3 over 4. Oh, I made the 3 negative. It's fine, just as long as one of them is negative. Negative can be wherever you want it. On top, on the bottom, in front. It's all the same. -3 over 4.
Plus 3.
-3 over 4 plus 3. Oh, I need the x. Good. And hey, does that line look like the line on your page? Is it almost like I used this graphing software to make that line? I did. That's true. But the cool thing too is Desmos will actually show you, you can make it a table. And I can put any value in for x. This is what I want to show you, because this is what I'm talking about. Let's say I was using this to figure out something really big. Let's say I needed, what's a really big number I could put in for x?
34.
34. It does the math for me. It uses the equation. I put the input in, it gives me the output. Now, we could have done that by hand because we have our equation here. I could set up y equals -3/4, and what you said, 34? Plus 3. And if I do that in my calculator, -3/4 times 34 plus 3, it gives me the exact same answer, -22.5. That is much quicker than making your graph bigger to go all the way to 34, right? Much, much, much quicker. Very efficient. So that's what we're doing here. So before we leave today, I want you to have this second graph done. That's going to be your exit slip to get out of here. So you got to get this guy done, and then we're out of here. We're done for the day. And then tomorrow we're going to be on the computer. We're going to be on Desmos, actually, learning some stuff about this. It's amazing. It's just, and it is so easy to use. Like, we always use the graphing calculators when I was in teacher's college, and you would spend 50 minutes explaining to kids how the graphing calculator works, 3 minutes doing math, and then your class is done, right? You do that. Desmos, you go down Desmos, kids just know how to use it because it'll take it lets you make so many mistakes, and it's just the modern era. It's like Google, it autocorrects. It knows how to make fractions and make them make sense. It's amazing. It's the best piece of technology I've ever used. Now, what do we got? Oh, that's great. Yeah, fantastic.
Pretty good. So it's 6. Is it 6 by 6?
6 by 1. Whenever there's no number underneath, then it's telling you the rise and runs always 1.
Okay.
Yeah, you make anything a fraction by putting 1 on.
Okay.
Yeah, hey, you did great. But just one thing I want. Yeah, not this year. This year is good, right?
You looked at my page and you
This
said drawing truck.
this year is 0. It does go up. It goes up 5. You got it. That was great.
That's why I did here.
You just one hand dab. You have the one hand dab. I don't even know what dabbing is, but I'm sure enough now. Where'd that come from? You doing that here, right? Yeah. Amigos.
But
I gotta be careful, Chip. Hit myself
Elsie, you done this one too?
Not
you
the
dab,
one.
Rudy. Rudy, do you dab? Do what?
Define a line, you just need to know what it is. What did you
Dab.
M and B. So you got the G is equal to 0. How do you find
Classic, the little technically classic.
Let's go.
But
that? Slope is always 1 over 1.
He does what he does every time he goes.
Why?
Yes, E.T.
So you
no.
gotta do 2 points. Yeah, I'm glad I couldn't do that. Are you hyper? I am not. Okay, let's start this one.
Right?
It's about the balance.
So, rise of 1, run the 5. Slope is always 1 over 1.
So you wonder?
The slope is 1 over 1.
It's actually so heavy.
And then equals to
Yeah.
Is this yours?
I don't know,
Where's
what's the
the
rise?
Is he another one now?
That's it.
What with this?
Now where's the line?
Brody. Brody.
Follow your line. When is it?
You have to message me tomorrow morning or tell me to remind you that I have to bring
Okay, so what's the line? Perfect. Why is this happening? So,
I watched that. Don't Brody copied me and I had the wrong answer.
Oh, yeah, it is what it is.
We got why you know that. This one, pick any X number you want and see what Y is. So you can calculate.
No.
So equate that.
negative 2.
And make sure it lands on your
That's the intercept. It's negative 2 here. Yeah, negative 1. So you put it there. Oh, no. Yeah, 2.
And that one.
Okay, so you go 3 over. So line 2 to 3.
So you're gonna say y equals you don't have to worry about, obviously. So then your m, what's your m?
And it's minus 1 over minus.
Okay, perfect. And 2 negatives make positive, so you're not wrong. You could put that in, make life easier. Since 2 negatives make positive, just stick with positive numbers. I want to be very clear. If you put -1 over -5, it's going to be the right answer. That is a good answer. It's just one of those things of like, if we're putting a tie on and shaving, we don't leave 2 negatives in. Not because it's wrong, it's wrong.
You copied me there.
Just 1 over 5. So put 1 over 5. 1 divided by 5. 1 down. Yeah. Divide by 5. Because division is fraction of this. It's the 1 up
Yeah, I gotta get that.
by 5. And then just before you usually get out of track,
I don't know, I just do my work, and then like, I put it in there, so I'm not explaining. Okay.
2 seconds.
Negative 1.
Okay, good.
Yeah, you know, it's not like.
And then put the number. What did you get?
First thing,
This is stupid.
I mean, you can't just use this. Okay. Now, you got the dot.
And then what was the d plus? What's it? No. No, does that fit on your graph? I have nothing.
I have faith that I'm getting something.
Now let's look. So if you go to there, so this says at -2. You have to go really less than finished.
Hey, that one.
That's great.
Not finished now. They got 2. Yeah, I still have math.
Yeah, okay.
You saw that.
Bad, right? That's why. Trust me, I've done 3. Not only is it gonna be easy,
Let's say you left it up.
but you're gonna find it
Wait,
easy and see how you can use it. And that's what really gets fun. You're like, oh, I can use it.
You wish I laughed like that.
Deeper than all of
That's
us,
that.
especially.
Yes. I think it's probably simple.
Where's your phone?
In fact, I think we need 40. The only thing I don't like is why
Go back.
now.
You gotta sneak it.
That's nonsense. Yeah, so why does one?
I did that the other day with all the kids you spot.
Language, boys, language.
I did that the other day with the juice spot.
So why?
Yes. You got that.
I want you to see something. Come with me. Come with me. Come with me. Hello. Hey, come here. You. How long is he?
Hey, Mr. Mando.
See you. Thanks for coming, eh?
No problem. Always heard something.
There you go. I had some left. This is my slightly condescending, you've almost got it, just a couple quick fixes and you're there version. You're welcome. So you can like hand those out to your friends when they've almost figured something out. Just come here, Dan. I want to show you something. Just 2 seconds.